Hello guys, Charlie from Gilponic here. Well, welcome for this video update. It's been a long time since I made a video like that, but yeah, today we can breathe a little and take a few minutes to set it up and make it so that you can see what's happening with your own eyes. A lot of things have happened since the Kickstarter, the original one, and a lot of changes has been made to the design of our kits. And those changes have been made so we can make your life easier, and also so that the product can be manufactured much more easier too. So here we have the two kits as they were at the campaign. This was the original one. So here we have the two kits, the one we had at the Kickstarter campaign and the final device right there. So the original one, as you can see, is very different in terms of size. Those modules are both water brain, but this one is much bigger than the new one. So what we did is to try to shrink all the sizes of those modules so that it's easier for you to put it in your grow room or a greenhouse or outdoor garden. And it's also easier for us to manufacture it on a larger scale, because it's printed, you know, it's 3D printed. So if it's smaller, we can basically print more of those for more people. What we've also changed is the layout of the connectors below, because it wasn't very subtle and simple and logic to use. So I've changed the layout so that you can access every BNC, you can access all the jacks connectors, the power supply very easily, and it will be less of a pain to put, for example, a sensor connector in it. What we've also changed is the layout for the sensor holder. At the beginning, we were using, at the Kickstarter, we were using this part. I don't know if you can see this correctly because my lighting isn't very great here. But you had the pH sensor right here with a thread so that you can screw the sensor in there, and the EC sensor was going here. And the problem with that solution was when you had to deal with those sensors, either to clean the sensor or to calibrate it, you had to unscrew the sensor. And it's something you don't want to do, unscrew a sensor with a very large thread, because your wire, you know, will curl at the end of the sensor. And it's more of an issue than normal when you have a 5-meter cable right here that will follow your sensor every time you make a turn. So what we've made is to make a system like that. So this system is more with a clip. Maybe you can see it here. Yeah, you see, you have a clip system so that you can put your pH sensor right here and your EC sensor right here. And how it works? Well, it's the same sensor as before, but we've added an interface part. For example, here you had the thread on the sensor right here, so we have this interface with now the clip male side. And when you want to put your sensor in the sensor holder, you just have to turn it a quarter of a turn. And same thing, you want to take it off, okay? And with the AC sensor, same thing, you can take it out, put it back in. And those sensors are level right here. And all this assembly is meant to be put directly in your water reservoir at the bottom of your water reservoir, so that even if you have a very low level of water, the sensitive part will be in contact with that water and avoid issues. Now, regarding the water pump, same thing, we have shrinked the module. So it's been shrinked in all sides, and it's good if you have a space that is limited. And also, a lot of people will use this module not alone, but with other pump modules around it, so that they have not 4 pumps, but 8 or 12 or 16. So it's much easier to have a smaller module if you need to stack them. That's just pure logic. And what we have decreased in size also is the tube that we were using. We were using here a standard 8mm pneumatic tubes. So those tubes are very great because it's reliable, it's easy to use, those connectors are just push to release, and also it will last in time. Because the material of the connector is quite thick, so it will not be cut easily. And what we've done is to take the size below 8mm, which is 6mm. Now we are using 6mm pneumatic tubes, which is better because it fits it's not as wide as before, and it's also easier to bend those kind of tubes than the big one right here, which are harder, you know. Now, regarding this harness, the other things that has changed is a very big thing. So we have decided that we would change the way we implement the pump that is supposed to push water in that harness. At the beginning, we had, once again, this part, and this part was with the sensors on this side and also the pump on this side. This block was in your water reservoir with the pump pushing water right here. The pump make each dose it needs to do, and the water goes back right there to be sprayed on the side. So what we found is that the pump that was here was not very efficient when the water in your water reservoir was near the lowest point. So what we've done is to replace the small pump we've had with the big one like this. It's a diaphragm pump, 12 volts, controlled by the water pump. So when there is a dosage that needs to be done, this pump will turn on, take water from the reservoir, pump it through the harness here, and will send it back to your reservoir. Now, this kind of pump is really good because it allows you to pump water and air. For example, at the beginning, this circuit is only air, you know, and with this pump, it can pull the water into the harness and apply quite a large amount of pressure to that water to be spread with that part in an efficient way throughout your reservoir. And all those connectors are 6mm and it's still pneumatic connectors, so it's basic push to release. So there is this black part here, I push it, I release the tube. I push the tube and I push the button, and that's it. It's holding and it's tight. So we have here the input and the output. The input, it goes there, sucked by the pump, up to the output, and then spread into your reservoir. And if you want to see more of the parts, you have the input here, and you have the output here. On the input side, you have, of course, your threaded connectors, your threaded pneumatic connectors right here, and you have a mesh filter from water tap faucet. And this filter will protect the pump from, for example, particles, roots that will be sucked by the pump. And also on the output, we have this little hole here. So when the pump, the diaphragm pump gets turned on, well, it will push the nutrient through that hole with quite a bit of pressure, meaning that the nutrients will not stay around. It will go and be spread into your reservoir. And our advice is that if you have the ability to have an extra aquarium pump that is dedicated to mix within your reservoir, it's still the best thing to have, because even with such a system, you cannot know for sure if your nutrients are shaken all the time within your reservoir. So having an extra pump for that, it's a great thing to have. And after that, well, that's basically it regarding the changes. So we have always stayed around the fact that all the parts can be replaced. So all the printed parts can be replaced by us because we make them. We have the 3D models and we make it available online later on. All the tubes, connectors are standards from some industries, so we know that we'll be able to source those parts all the time. The sensors are also from the industry, so if we need to replace that, we can. And regarding the electronics inside the boxes, well, we make it ourselves, and same thing, in a worst case scenario, the electronics goes down, we're able to send you a new circuit board to replace the bad one. Now, regarding the software, I will make an extra video within the next few days to show you what we've done with the application. Because it's not a great way to film it with this kind of setup. So I'll make a special one for you guys and show you how it works, how you can set it up and so on. Now, regarding something that's very important to you, delays. Now, at the beginning we were with an ETA in March. It was something we thought was possible, but we've had some very not so nice surprises. Two surprises in particular. We've had delays for the application certification process to have the right to be on the iOS store and the Android application store. So that process has been done. And now the GreenPonic application is available on both of those stores under the banner GreenPonic, and it's a beta version right now, but it's the working version. Now, if you don't have a kit, you will not do anything with this app, because this app is made so that you connect, the app will connect to a kit, and if it doesn't see a kit, it will not show you any interface. It's quite a basic app at the moment. So I will make a video to show you guys all about that. And also we've had a lot of delays due to electronics. So in those modules, you don't have a lot of things. You don't have cables everywhere. You only have a circuit board that is fixed with 4 screws, and that circuit board is linked to the buttons on the sides, to the pumps with some clips, and same thing for this module. So those circuit boards were made. We've made a few of those for testing during February, and what we saw is that we were the victim of shortages on the component sides for those circuits. I'm not sure if everyone knows, but since last summer there are some very important shortages worldwide. At the beginning it was only for very complex components, CPUs, GPUs for computers, but after months and months it became more and more common on other kinds of parts. For us, it was on very simple stuff, capacitors, for example, very small capacitors that wasn't an issue at the time that had to be changed, so stuff like that. And when you change something on a circuit board, you have to change the plan of your circuit board. So what we did is back in March, by the end of March, we were thinking, okay, do we keep the design and take the risk that within a few weeks or months we will not be able to produce it anymore and it will be a mess later to make new units? Or do we make the choice to make those changes right now and to start on the right foot, meaning that we use components that we know will be available in the near and less near future. So that's what we did. The thing is, with this process, you very easily lose 1 month, 2 months, maybe 3 months. Because this process is the following. When you make a change, you change the schematic, and after that you will buy some PCBs in China lots of the time, and you will have to wait for the PCBs to come. So this is 1 or 2 weeks. And when you get it, you have to assemble all your components, your new components on your PCBs to see if it all works as intended. Because sometimes something works on paper but not in reality. So you do that, you lose several days. And after that, if it's all good, well, you can buy a large amount of PCBs, of circuit boards, sorry. You buy those circuit boards with all the components and you make them assemble by a company that make PCB assembly. And then you lose, again, between 2 weeks to 8 weeks. So you see, if you do the math, you're easily 1 month to a year, sometimes 3 months more than expected. So our plan right now has worked, meaning that we have made those changes and we are expecting the PCB to reach us within a few days. So we will ship the first units on the May the 3rd, and we will ship all along the next month in May. So we will not be able to make one big shipment everyone at once, but what we will do is we will contact you one by one to tell you, okay, we'll be able to ship your unit on this week. Will you be available? Is it okay? Are your address still good? Your phone number still good? So that we do everything perfectly. Okay, so I want to say we are very sorry for that delay, but at the end of the day, we could have sent units in March, but we would have had issues in the long run. You know, it just wasn't worth it. So very sorry about that, but be sure that now you will get a product that is reliable, that will last in time, and that if something happened during the warranty or after that, you'll be able to get the parts you need to make it work, not forever, but near forever. Okay, so that's it for today. As I said, I will make a new video for the software parts, maybe also on the 3D printing small farm we have here. In the meantime, if you got questions, don't hesitate to contact me on KickStarter with a message or on email at contact@greenponic.com. It's not always very easy to reply quickly, but we try to do this as well as we can. You have to know that at the moment we are working with other people outside from the company to make the software, to help us with manufacturing. But basically within Greenponic we are still 2 people in that adventure. And it means that we don't have sometimes the time to reply very quickly, but we reply at one point. And it's not a situation we like, but we do with what we have, and it will get better and better within the next months or so. And basically what we did until now is to limit the quantity of content to make on social medias, content such as videos and so on, because it takes a lot of time, and we chose to put an emphasis on make those deliveries happen as fast as possible. Yeah, just basically we are open to conversation, to question, to everything, so don't hesitate, and I will be back to you soon for another update. Talk to you soon. Bye.